Hi, this is Hai Xiaowang, and today we're going to talk about the combination sum 2 and given the collections of the candidates' numbers and target number, find all the unique combinations in candidates where the candidate numbers sum to target. And we should pay attention that each number in the candidates may only be used once in combinations. And unlike the combination sum, which we can use one element for many times, in this case, each number can only use once, and the solution must not contain the duplicate combinations. So for this case, actually the candidates may have a duplicates. After sorting it, for example, the candidates can be 1, 1, 2, 2, 7, 10. And if the target value is equal to everything, equal to 5, and first we got the first element here, which is 1, and then we just search the valid combinations, and we found 1, 2, 2 is a valid subarray set equal to, sum it up, and it's equal to the target value, which is 5. And then we just go backtracking and start with 1. And we found that we can still find the same subarrays, which is 1, 2, 2. And so in order to prevent this case from happening, actually for any duplicates numbers, we only use the first element. Here we just use this one, and we will not use this one. So how to do that is that achieve this is that by using array, which denotes for the status whether the element is used or not for each element. So here we just start as the false for just copy that. And 1, 2, 3, 4, 5, 6. There are some. And first we are just change this to like this one, and then we just find out as the first one and these two, and this will be like this. And when we start when we try to visit this second element, we found that there is an element that has equal values of the current values, which is 1, and it's not used. So we can just skip this number. So we will just now visit the second one and just go to the 2 and find the rest of the combinations here. That's about the corner case about the duplicates combinations here, and the rest of the code is just similar to the combination one. So let's just code it out. There are 4 parameters. The first parameters denotes for which index we should start to enumerate in our candidates array, and the second denotes for how many values we should sum it up to target, and the third parameter is current list, which is current combinations, and the last element is just a use array, which denotes for status I just mentioned before. So if t is equal to 0, which means that we've already find the valid combinations. So just like this. And if CU is equal to the candidates, which means that we already visited all the candidates, so we just return. And then we just go for enumerations from U to, and if the candidates asked is greater than the target is NT, we just return because the candidate is already sorted. So if the current status is greater than the T, the rest of them will all be greater than the target value. So it's like puring the process. The second if conditions is to solve the duplicate combinations. So greater than X and candidates is equal to -1 and not used X -1, which is just the case I just mentioned before. We got to continue, and if not, and candidates, and we should restore it and update it to be the true. And then go to the recursion part, which is U X plus 1 and T minus candidates, which means that we already append these values to our current list, current and used. Start from 0 index and the target and the current sum, which is an empty list and used. And I think it's pretty much about the code. Let's see. Last thing. There will be 2, 1, 7, and which means that this part didn't solve the count cases. Is that I write note here? Yeah, let's try it. Yeah, it seems to work. That's pretty much about these problems. Thanks for watching.